Hi guys, welcome to lesson 102. First of all, we're going to be talking about transversals and then we'll move on to talking about simplifying expressions. So we did transversals last year, so this should be a review, but there's a lot of vocabulary that you may have forgotten. Okay? So when we're talking about a transversal, we mean a line that intersects two or more other lines. Okay? Now the special situation that we're going to talk about is when parallel lines are intersected by a transversal. Okay? So when we have a set of parallel lines like these two right here, this would be our transversal, and it intersects both lines. And you can see that 8 angles are created when that happens. Okay? Now, we have interior angles. That means angles that lie inside of the parallel lines, these 4 here. Exterior angles lie outside of the parallel lines. Okay? Just like that. Okay? So, let's move to some more vocabulary words dealing with our angles. Okay. The first vocabulary word. Remember, pause your video, get these notes in your notebook, get these definitions in your notebook, okay? Corresponding angles. Corresponding angles are congruent. They're on the same side of the transversal and on the same side of each parallel line. Okay, the best way to learn this is to just identify the corresponding angles. So let's look at angle 1. Okay, so we are looking for a congruent angle. That means the same size. That lies on the same side of the transversal and the same side of a parallel line. Okay, so angle 1 is to the left of the transversal and it's above this top parallel line. So down here I need to find an angle that is to the left of the transversal and above the parallel line. Hopefully you see that it's angle 5. Angle 1 and angle 5 are corresponding angles. Let's look at angle 2. Angle 2 is to the right of the transversal and above the parallel line. So we need another one that's to the right of the transversal and above the parallel line. So hopefully you see that it's angle 6. Angle 2 and angle 6 are congruent. They are corresponding angles. Okay? Same thing for 3 and 7 and 4 and 8. Okay? Corresponding angles. One thing you need to notice when we have a transversal that intersects a pair of parallel lines is that we have 8 angles created, but 4 of them are acute and 4 of them are obtuse. All the acute angles have the same measure, and all the obtuse angles have the same measure. It's kind of a neat situation. Alternate interior angles. Oops, I put my finger up too far. Alternate interior angles. Alternate means on opposite sides of the transversal. Interior means inside of the parallel lines. Okay, so I'm looking at angles 3, 4, 5, and 6. Those are interior. So I'm seeing which angles are alternate angles. 3 and 6 are on alternate sides of the transversal. 3 and 6 are both acute angles. They are alternate interior angles. 4 and 5 are alternate interior angles. Okay? And then the last one, alternate exterior angles. Alternate means they're on opposite sides of the transversal. Exterior means they're outside of the set of parallel lines. So we're looking at 1, 2, 7, and 8. Which ones are alternate exterior? Looking at angle 1, I need an angle that is also exterior, but it's on the opposite side of the transversal, but it's congruent. Angle 1 is obtuse, angle 8 is obtuse. Angle 1 and angle 8 are alternate exterior angles. 2 and 7 are alternate exterior angles. Okay? Here's just some things that we need to know about when parallel lines are crossed by a non-perpendicular transversal. So what that means is we're not talking about this. That is perpendicular. We're talking about non-perpendicular. So we want our transversal to cross like this or cross like this, something like that. Okay? So, all the obtuse angles that are created are congruent. All the acute angles that are created are congruent. Any acute angle and obtuse angle together are supplementary. So if I'm looking back at this one that I created a minute ago, if I combine angle 1, which is obtuse, and angle 2, which is acute, if I put them together, they have to be supplementary. Okay? Any one of the acute angles combined with any one of the obtuse angles has to be supplementary. Okay? So let's look at this example. Parallel lines X and Z, so X and Z are my parallel lines. They're crossed by transversal T. we say in our directions that angle 7 measures 35 degrees. That's here, 35 degrees, okay? So using the knowledge that we have from this previous slide, that all obtuse angles are congruent, all acute angles are congruent, and any acute angle and obtuse angle are supplementary, pause your video and see if you can figure out what all the rest of the angles measure. Okay, so you should have said, well, angle 7 is an acute angle. It measures 35 degrees. Guess what all the other acute angles in the figure measure? 35 degrees. So this is 35, this is 35, this is 35. Okay? Now we said any acute angle and obtuse angle have to be supplementary. 180 minus 130, or minus 35 rather, leaves me with 145. So angle 6 must be 145. That means all the other obtuse angles in my figure have to be 145. So if I know one of the angles in a transversal problem, I know all of the angles. Okay? Now this last part says to name a pair of corresponding angles, alternate interior angles, and alternate exterior angles. Go ahead and pause your video and see if you can name one of each of these. Okay, corresponding. Okay, corresponding basically means it's the same size, two angles that are the same size and are there in the same position in our figure. So, I'm going to go ahead and erase all that so I can see my numbers. If I'm looking at angle 1, the corresponding angle to angle 1 is to the right of the transversal and above a parallel line. Angle 5 is to the right of the transversal and above the parallel line. So 1 and 5 are corresponding. 2 and 6 are corresponding, 4 and 8 are corresponding, 3 and 7 are corresponding. So you should have chosen any of those pairs for this A. Alternate interior. Okay, so interior angles, I'm talking about 2, 3, 5, and 8. Alternate interior, 3 and 5 are alternate interior angles, 2 and 8 are alternate interior angles. Okay, last one, alternate exterior angles. Okay, so I'm talking about 1, 4, 6, and 7. 4 and 6 are alternate exterior. 1 and 7 are alternate exterior. Okay? Those are just definitions that you have to memorize, guys. Okay? Okay. Now let's move on to simplifying expressions. Okay, just got to change gears. We are talking about solving for a variable. Okay? Now, collecting like terms is sometimes involved in solving equations. Okay, we've been doing a lot of solving equations. We've been doing a lot of collecting like terms. Now we're going to combine them together. Okay? So if I've got something like this, 4x plus 6 minus 2x equals 18 plus x minus x. Now, I look at either side of my equal sign first. So on the left side of my equal sign, is there anything that I can collect? Well, over here I have some x's here, and I got x's here. I got positive 4x's here, negative 4x's here. They combine to make 2x plus 6 on the left side of my equal sign. Okay, so I combined my negative 2x and my 4x, and I got 2x. Over here on the right side of the equal sign, I had positive x, negative x, so now I have 0 x's. I don't have any x's. Okay, so I've simplified this to 2x plus 6 is equal to 18. Now we're ready for our questions that we ask ourselves. What's the term containing the variable? 2x. What's happening to 2x? It's being added by 6. How do I undo add 6? Subtract 6 on both sides. Now I get 2x is equal to 12. Now what's happening to x? It's being multiplied by 2. How do I undo multiply by 2? Divide by 2 on both sides. This reduces. 12 divided by 6. 12 divided by 2. X is equal to 6. Okay? So we're just going one more step in combining what we know about collecting like terms and what we know about solving for a variable. Okay? We even need to collect like terms from either side of the equal sign sometimes. Okay? So let's look what's going on here. 3x minus 12 equals x plus 4. Okay? So I look on the left side of my equal sign. 3x minus 12. These are not like, so I can't combine them. I look on the right side of my equal sign. X plus 4. These are not like, so I cannot combine x and positive 4. But 3x and x are like. Okay? So I've got to figure out how to get them together from across either side of the equal sign. Okay? Now this is the hard part. Okay? Now, I want to move this x over there to be with those 3 x's. Okay? Now what we have to do is we have to look at that x and say, is this a positive x or a negative x? This is a positive x, okay, which means plus x, right? So how can I get rid of a plus x? Well, I can subtract an x. If I have plus x minus x, I don't have any more x's there, right? But if I'm going to subtract an x, I got to do it on both sides, okay? So I want to subtract an x here because I want to get rid of this x on this side of the equal sign. Subtract an x here, subtract an x here. So now when I combine it, this is gone. 3x and a negative x leave me with 2x minus 12 equals 4. Okay? So now I have all my x's together. Now I can go back to my questions, right? What's happening to the term with the variable? It's being subtracted by 12. How do I undo subtract 12? Add 12 to both sides. So now I get 2x equals 16. What's happening to x? It's being multiplied by 2. How do I undo multiply by 2? Divide by 2 on both sides. This reduces x is equal to 8. And remember how you can check yourself. Okay, I'm saying x is 8. So I can go way back up here and I can put an 8 in for x. 3 times 8 is 24 minus 12 equals, and I said I'm going to put an 8 in for x. 8 plus 4. 24 minus 12 is 12, is equal to 12. Is that true? Yes. So x was equal to 8. Okay? So when we solve for a variable, we can always know if we did it correctly. Okay? Okay, one more. Let's try this. 2x plus 3 times x minus 3 is equal to 6. Okay? So you can see here that we've got to do some distribution first. Okay? So I'm going to just rewrite my 2x plus 3 times x is 3x. Positive 3 times negative 3 is negative 9 is equal to 6. Now I'm going to look on the left side of my equal sign. Is there anything to combine? Yeah. I have a 2x and a 3x I can combine. That makes 5 x's minus 9 is equal to 6. Now our questions. What's happening to the term with the variable? It's being subtracted by 9. How do I undo subtract 9? Add 9 to both sides. 5x is equal to 15. Now what's happening to the variable? It's being multiplied by 5. How do I undo multiply by 5? Divide by 5 on both sides. X is equal to 3. Okay? So we're just taking it one step further, guys. Okay? We are using our combined like terms knowledge. We're using our solving for a variable knowledge. What we've mainly added today is doing this across the equal sign. Okay? Remember, an equal sign means that the left side and the right side must be balanced. If I do something to the left side of the equal sign, I got to do the same thing to the right side. If I do something to the right side of the equal sign, I got to do the same thing to the left side. Okay? I want you to go ahead and pause your video and do your practice set A through J, and then start it back up again and we'll check your work. Okay, A through D has to do with our transversal problems. Okay? So on A, they want to name 4 pairs of corresponding angles. Okay? 4 pairs of corresponding angles. So you should have chosen S and U, T and V, W and Y, X and Z as corresponding angles, okay? B, 2 pairs of alternate interior angles. Alternate interior, so our parallel lines are this way, so we got to go inside here. T and Y, U and X, alternate interior. C is alternate exterior. Okay, so we've got to go outside of the parallel lines. You should have chosen Z and S, W and V as your alternate exterior angle pairs. Okay? Angle number D, letter D. If the measure of angle W is 80, what's the measure of all the other angles? So all the other acute angles should be 80. So W is 80, T is 80, Y is 80, V is 80. Okay? And then 180 minus 80 is 100. That means all the obtuse angles measure 100. X and S, Z and U all measure 100 degrees. Okay? Okay. Now for the harder part. Practice set. 3W minus 10 plus W equals 90. So what I did here was I combined my 3W and W. I got 4W minus 10 equals 90. Okay? So then I said, what's happening to the term with the variable? It's being subtracted by 10. How do I undo that? Add 10 to both sides. So now I have 4W is equal to 100. What's happening to W? It's being multiplied by 4. I undo that by dividing by 4 on both sides. That makes W equal to 25. Next, x plus 10 plus 2x minus 10 equals 180. So over here on the left side of my equal sign, I had an x here, 2x here. They're all positive. So that makes 4 x's. Then I have plus 10 minus 10. So I don't have any more 10s. I don't have any more numbers. Plus 10 minus 10 makes 0. So I just have 4x is equal to 180. What's happening to x? It's being multiplied by 4. How do I undo that? Divide by 4 on both sides, and x is equal to 45. 3y plus 5 equals y minus 25. So on this one, I have to get my y's together, but I've got a y on the left side of the equal sign and a y on the right side of the equal sign. Okay? So this is a positive y. So to get rid of it from the right side, I have to subtract a y. Plus y minus y gives me no y's. But I got to do that to both sides, right? So this is gone. 3y minus y is 2y plus 5 equals negative 25. How do I, what's happening to the term with the variable? It's being added by 5. How do I undo that? Subtract by 5 on both sides. So now I have, this is gone, 2y is equal to negative 30. Divide by 2 on both sides. Y is equal to negative 15. 4n minus 5 equals 2n plus 3. Again, I want all my n's together. So this is positive 2n, so to get rid of it, I subtract 2n on both sides. 4n minus 2n, that's 2n. These are gone over here. 2n minus 5 is equal to 3. Now I want to add 5 to both sides. 2n is equal to 8. Divide by 2 on both sides. N is equal to 4. 3x minus 2 times x minus 4 is equal to 32. We have a distribution. So I've got 3x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8 equals 32. Now I have 3x minus 2x. These are both x's. I need to combine them. 3x minus 2x leaves me with x plus 8 equals 32. How do I get x by itself? Subtract 8 on both sides. X is equal to 24. Last one. I got a distribution here. 3x is equal to 2x minus 8. 2 times x is 2x. 2 times negative 4 is negative 8. So now I want to get my x's together. This is a positive 2x, so if I subtract 2x, I won't have any more x's over here, but I got to do it to both sides. So now I have x is equal to negative 8. Okay? Okay, guys. This was our next to last lesson, so the next lesson you watch will be the last lesson we do this year, okay? Hope you guys are well, and I miss you all. Bye-bye.